Hey guys, so today we're going to go over half-life and we're going to talk about some of the features of half-life, and we're also going to look at alpha-beta reactions a little bit. Okay, so you learned that unstable nuclei are going to try to regain stability by doing a nuclear reaction, and it can either undergo alpha, beta, or gamma decay. Well, there's a video that we'll be watching, and there's a worksheet that accompanies that. So I'm going to play the video through this so that we can do the worksheet together. That's what we did in class. So I'm going to press play.
Phosphorus 32 is radioactive and undergoes beta decay. So we talked about beta decay in the last video. Here's our beta particle, and the phosphorus is going to turn into sulfur. So let's say we started with 4 milligrams of phosphorus 32, and we wait 14.3 days, and we see how much of our phosphorus is left. You're going to find 2 milligrams of your phosphorus left. The rest has turned into sulfur. And this is the...
So he just said a lot of stuff, and we are now going to answer our questions based on what he just said. Okay? So we're going to go back to our worksheet. And the worksheet is asking us, first of all, what type of reaction is he showing? He being the guy in the video that we can't see, we can just hear. He said that it was beta, so you can either write beta or you can circle. How do you know? So it's beta because he showed a letter B, okay? But I'm going to write the E with 0 and a -1. He showed that particle. And because he told us. All right. So then it says draw the reaction for phosphorus here. So we can go back to our video and look at that real quick. It is P with a 32 on top, a 15 on bottom, and then we got our products. I'm going to write that for you so you don't have to sit here and pause your video. So the reaction is P with a 32 on top, 15 on bottom. Write this on your paper, okay? So we will be checking you. So after you have that, you're going to write your particle. I know he wrote a B, but I'm going to make it an E because that's how you're going to see it on your test. And then your product is going to have 32 minus 0 is 32 on top. The bottom is 15 minus a -1, which is 16, and that is going to be sulfur. Okay? And then he also answered number 3. It says how much of phosphorus was lost after 14.3 days. He's in the reaction or in the video, he starts with 4 grams. Then after 14.3 days, it became half that amount, which is 2 grams. So how much of phosphorus was lost? Half of it, which was 2 grams. Okay, and then we have to define half-life. He's about to do that in the video. But just so we're not going back and forth quite that much, half-life we'll go ahead and define. So you should be writing this down, and if you didn't get this written down, you should pause the video. You can do this at your own pace, okay? So, define half-life. It is the time it takes for 1/2 of a sample to decay. It does the decay radioactively, but you get the gist, okay? So then it's asking what is the half-life of P32? What did it become after 14.3 days? Let's look back at that, okay? The half-life of P32, I want you to notice, is if we started with 4 milligrams and it decreased to half of that amount in 14.3 days, then 14.3 days is its half-life. And then the other question was, what did it become? What element did this become? It became sulfur. So we're going to write that down. So half-life is 14.3 days. Second part of the question, what did it become? Sulfur with a 32 on top. and 16. Or you could have just written it like this, S-32. That tells us what the element is, okay, and then this is its mass. Same information, the atomic number doesn't have to be given because that's always the same on the periodic table. All right, number 6. I did this with the class and didn't really hear a good definition for the rate of decay, okay? So this is really how fast something radioactively decays. Now, this is not going to be on a test, so don't worry about number 6's definition. All right, well now he's going to talk about something that has to do with a graph, so let's watch the video for just a minute.
The idea of half-life.
And he's going to define
half-life. Let's look at the definition for half-life here. It's the time it takes for 1/2 of your radioactive nuclei to decay. So if we start with 4 milligrams, right, and we lose half of that, right, then we're left with 2 milligrams. And it took 14.3 days for this to happen. So 14.3 days is the half-life of phosphorus 32. And this is the symbol for half-life. So 14.3 days is the half-life for phosphorus 32. So the half-life depends on what you're talking about. So if you're talking about something like uranium-238, the half-life is different. It's approximately 4.47 times 10 to the 9th in years. So that's obviously much longer than phosphorus 32. We're going to stick with phosphorus 32 in this video, and we're going to actually start with 4 milligrams every time in this video, just to help us understand what half-life is. Next, let's graph the rate of decay of phosphorus 32. And so let's look at our graph here. And on the y-axis, let's do the amount of phosphorus 32, and we're working in milligrams here, so this will be in milligrams. On the x-axis, let's do time, and since the half-life is in days, it just makes it easier to do this in days. All right, we're going to start with...
So in our questions, we are being asked what goes on the x-axis and what goes on the y-axis. So we're going to go ahead and answer those questions. X-axis is going to be time. Y-axis is the amount. And so we are going to label that on this graph. This graph then is going to have, so this is asking us to follow him and do the graph on this graph paper. So we're going to do that. We are going to label this amount on the x-axis. He was like super extra thorough and did parentheses and wrote the units. That's not necessary. This is the amount, and then x-axis is time. And then he's also going to like mark this up. We start at 0, but then if we skip every few of these, we can do 1, 2, make that a 3, and then make this a 4, okay? And then we'll do the time every 14.3 days. This is 14.3. This is 28.6. So we're adding 14.3 every time, okay? So 14.3 plus 14.3 is 28.6, plus another 14.3 is, if I am remembering right, I think this one's 42.9, and then this one's like, I don't know, 50 something. We'll see. All right. So he's going to continue with this, and then we're going to do this on our own graph paper. What did I do? Okay, hang on. Let's find it again. Okay. Almost there, almost there. Wait, he's graphing it now, isn't he? Okay. Hold on. Do you see what I keep doing? Dang flabbit. It's all right. I'm just here for your entertainment.
Days. All right, we're going to start with 4 milligrams of our sample. Let's go ahead and mark this off. This will be 1 milligram, 2 milligram, 3, and 4. So we're going to start with 4 milligrams. So when time is equal to 0, we have 4 milligrams.
So your first point is always time is 0.
3, and 4. So we wait 14.3 days. So this is 14.3 days, and half of our sample should be left. So what's half of 4? It's of course 2. And so we can go ahead and graph our next data point. So there should be 2 milligrams left after 14.3
Just easy
days.
peasy,
So that's our
hopefully.
point. All right, we wait another 14.3 days, so we wait another half-life. So after 2 half-lives, that should be 28.6 days. All right, so we know that after 28.6 days, that's another half-life. So what's half of 2? It's 1, of course. So that's our next point. So after 28.6 days, we should have 1 milligram of our sample. Let's wait another half-life. So 28.6 plus 14.3, right, should be 42.9. So
how much is going to be left?
Point.
What's half of 1?
And what's half of 1?
It's half.
It's 0.5, of course. So in here, right, that's about 0.5. And so that gives us an idea about where our next data point is. And we could keep going, but this is enough to give you an idea of what the graph looks like, right? So if I think about this graph, right? This is exponential decay. So
all right, so let's go back to our paper and let's graph that. And so we're going to do our first point is before any half-lives occurred, we started with 4 grams. So we always have our time is 0 at the beginning. First half-life, it's going to go down to half. Next half-life, it goes half of that amount. And then the next half-life is half of that amount. All right. And then if we graph it, we get our graph. Okay. So if I didn't play through him drawing this, I would ask you if this is a straight line, and the answer is no. So in math, you learned that this is like a hyperbola, and a hyperbola is kind of like half of a parabola. And it's going to go really, really, really close to the origin. It's never going to reach 0. It's just going to keep decreasing, and it's an exponential decrease. So it's an exponential decay. What other questions do we need to answer on our sheet? Because I think there's a couple of questions we can answer before we get to the rest of the video. As half-life increases, what happens to the amount? Remember, the amount's on the y-axis. So the amount decreases. All right, so we can answer number 9. And if we started with 4 milligrams of phosphorus, how much is left after 57.2 days? Well, guess what? 57.2 is not something that we plotted, but we can do it. So 57.2 is actually our very next half-life. So this was at 0.5. So we just got to cut that in half again. So what is that? 0.25. Good job. So obviously I didn't draw this exactly right, because that should be here if the 0.5 is there. Anyway, so it should be right there. And so our answer is going to be, where are we at? 0.25, and it's not grams, it's milligrams. Good thing your test is multiple choice. You don't have to worry about your teacher getting the unit wrong. All right, then it says how many half-lives went by for that sample to decrease to 0.25. So how many half-lives did we go through? Well, we're going to look back at the graph. We went through 1 half-life, 2, 3, 4. So it's 4 half-lives. Now, number 12 is actually asking us a different question that requires that we do like a little data table. And we're going to do a data table for a different video. So I'm going to leave that alone. And I am going to just let you know that this next graph, we actually have to graph the whole thing. Then we have to decide the half-life by figuring out half of our original sample and finding out what the time is that corresponds to that. And it's like just under 2.5 years, okay? And that's it.